Europe should be a center for AI, computer science, and all technology moving into the future. But Europe has to choose to participate.
Hello, we are here at Web Summit in Lisbon, and here with me is Rev from Nvidia, and we're going to talk about robotics. So Rev, how big is the next phase of AI? Is it physical AI? Is it robots? What's going to change?
Well, we're not really done with the current phase of AI. That's already a huge opportunity, and we're just at the very beginnings of that. But as we're creating this phase, as we're developing this phase, which is all about knowledge AI, about agents that work within the knowledge space and the digital space that knowledge workers work in, we're also developing the AI for the physical world. We're taking these same agents that we're infusing with advanced intelligence inside the digital world, and we're giving them bodies so that they can come out into the real world and affect atoms, not just ones and zeros. The opportunity for this is much, much larger than the huge opportunity we already have in front of us for the knowledge AIs, because the industries that are about atoms, about physical things, are much larger than information technology.
Okay, so we're talking about Omniverse here, so robots being trained in a kind of another virtual world. What is the uptake on that? Are you getting a lot of companies that are interested in this?
In order to build a physical AI, to build robots that have advanced brains, you first need to train them somehow. You have to create this brain. And to create the brain, you need to give it experience, life experience of some sort, for it to practice and train in. The only way to really do that is to have these robots learn inside a virtual world, inside a simulation. To build and operate robots, you need 3 computers. You need a computer that's in the robot, that's the one that actually operates or powers the brain of the robot. You need the AI computer that produces the brain that you put into the robot computer. And you need a simulation computer that is the playground where the robot learns how to be a robot and feeds the AI computer with all the data necessary to produce the appropriate brain. Nvidia's platform, our operating system for this computer, is called Omniverse. This is a collection of technologies that we have created that takes advantage of the accelerated computing and AI that we have in our computing stack in order to simulate physical worlds accurately enough so that we can use them for these purposes, for training and for validating the robot brains we create.
What kind of robots are we going to see first? Are they going to be in factories? Are they going to be out in our homes? Where will they be?
That's a big question, and different people have different opinions about this. Personally, I believe that we're going to see them in industrial spaces first. It makes sense because the demand there is already very clear. We have a global shortage of labor in these kinds of physical industries, particularly the ones that have the 3Ds, jobs that are dull, dirty, and dangerous. We don't have enough young people who want to do these jobs, and we have an aging workforce that's retiring out of these jobs. The consumer space is less clear. Consumers tend to be fickle, and they tend to have different wants and needs. And consumers also need it to be a lot less expensive. It has to be a lot safer. But it will happen there for sure. It's just more likely to happen in industry first.
I mean, I think talking about safety there, AI itself, generative AI, we're still not there yet. It still makes things up. There's still, biases. There's still a lot of societal issues. So how is this going to change with robots? Will there be a safety benchmark? Can we really trust these robots coming into our home?
In some ways, the kind of safety we're talking about with physical robots is easier to test than guardrail than the type of safety people are talking about generally with these agents that can be your friend or characters and whatnot. With physical robots, we can measure safety just based on how they behave. We want our self-driving cars to drive safely, not get into accidents and do the sorts of things that we expect good human drivers not to do. That all being said, it's not like humans are also the safest. So to some extent, it might actually be easier for us to guardrail these physical robots because we can use these same benchmarks for safety as guardrails on them directly, as opposed to machines that are operated by humans.
You've just launched the robo-taxis with Uber. Tell us more about that. How are we going to keep autonomous driving safe? Because yes, AI is going to enable much more of that technology to be done fast, and Nvidia's promising stage 4, is that right?
Yes, level 4.
It's level 4 driving, okay. So how do we keep that safe, especially when it comes to vehicles?
One of the most important aspects of developing good AI, especially safe AI, is to have a diverse set of data that you use to train it. What you need in a self-driving car, the AI for the self-driving car, is for it to have experience in the long tail of events that are unlikely to happen, but when they do, it can be very tragic. The way we help solve for that is twofold. One, we can actually construct those scenarios in the virtual world where it's very safe. Things like children running out into the street while the car is barreling down at high velocity. We wouldn't want to do that in the real world, but we can do it there, and we can collect all of this data. Then also, once you have deployed these self-driving cars, you can start collecting data from the real world, and anytime there is behavior that doesn't quite match what we would like, that goes back into the data set to train the next iteration of the robot brain. So they'll continually get better and better because we'll have more data from the real world that can feed into these simulations to create more diverse scenarios, and they'll I think very quickly become better drivers than all humans.
Okay, my last question. For this kind of technology, it's power hungry, you need a certain kind of infrastructure. As we're at Euronews, I want to ask you, does Europe have the correct infrastructure when it comes to building out these kind of AI models?
So there's obviously already lots of energy available in Europe. How much of it can be freed up for AI is a big question, but that's a choice. That's a choice that Europe can make in terms of building out new energy, as well as allocating the available energy or maximizing the potential of the energy generation given the infrastructure that's already in place.
Okay, really last question here. We always talk about the AI race when it comes to US, China. Where does Europe fit in? Can it keep the pace?
It certainly can keep the pace if it chooses to. The talent necessary for AI, the key part of producing AI is first having the talent and the know-how. And a lot of these technologies and a lot of the ideas around AI they originated in Europe, particularly in the UK. Europe should be a center for AI, computer science, and all technology moving into the future. But Europe has to choose to participate. And in order to do that, it first starts with having the foundational infrastructure necessary to allow your researchers, your innovators, your startups, and your enterprises to build. Without intelligence infrastructure, without the AI factories, and without the energy to power them, it won't matter how much talent is available here. But if Europe chooses to do this, then it certainly can be leading.
Okay, thank you so much, Rev, and enjoy Web Summit.